In this class, we are going to discuss the proof of the relation between beta function and gamma function. And we know that this is a popular relation between beta function and gamma function is beta mn. This is equal to gamma n by gamma m plus n. Now we have to prove this relation. We first write the definition of beta mn, the definition of gamma n and gamma m plus n. Okay, we know that beta mn this is equal to integration 0 to 1 x to the power m minus 1 into 1 minus x to the power n minus 1 dx. Okay, and also we know that beta mn is symmetric about m and m, that is beta nm this is equal to beta mn and this is the same as this. Now if we put x equal to cos square theta, then we get dx this is equal to 2 into cos theta into sin theta d theta, there will be a minus, then we get this result as cos 0 means pi by 2 and 1 means 0, and this is minus because dx here, and this is cos 2m minus 2 into 1 minus cos square theta, this is theta, n minus 1 into minus 2, sorry, we already write minus here and also we write 2 here, and this is cos theta sin theta d theta, and changing the range of integration as 0 to pi by 2 and cancelling minus, we get cos to the power 2m minus 1 into sin to the power 2n minus 1 theta d theta, because this is 2m minus 2 and this is to the power 1 and this is sin square theta, so sin square 2n minus 2 plus 1, this is sin to the power 2n minus 1 theta, and this is beta mn, and we get this integration as beta mn by 2, right? This is the first result. Now we know that gamma m this is equal to integration 0 to infinity e to the power minus x into x to the power m minus 1 dx. Here we put x this is equal to r square, then we get dx this is equal to 2r dr, and get integration 0 to infinity e to the power minus r square into r square to the power m minus 1 into 2r dr. So we get 2 into integration 0 to infinity e to the power minus r square into r to the power 2m minus 1 dr, because here r to the power 2m minus 2 plus 1, so this is r to the power 2m minus 1 dr, and we write this relation as half into gamma m. Similarly, we can write half into gamma n this is equal to integration 0 to infinity e to the power minus r square into r to the power 2n minus 1 dr, and half into gamma m plus n this is equal to integration 0 to infinity e to the power minus r square into r to the power 2 into m plus n minus 1 dr. We write this all relation here. Okay, this relation, this relation, this relation, this relation, this all relation we are used in this proof. Okay, now we consider a region as, we first consider a circle of radius a, okay, and we consider a square like this, right? Now also we consider another circle of radius is like this. This circle, okay. This is not look like a circle, but we assume here this is a circle, okay. And we consider only the first quadrant of this region. That is, we remove all the other quadrant from the figure to show prominently first quadrant, right? And we name the first circle. This is R1 and this is equal to x square plus y square. This is less equal to a square because the radius is a and radius is a, okay. And the secondly, this is a square of side a, and this is r, and this is given by x, this is equal to x, this is equal to 0, y, this is equal to 0, x, this is equal to a, and y, this is equal to a. This is a square. And the third region is R2 is given by x square plus y square less equal to a root 2 whole square, because this is a, this is a, this is a. So the diagonal of the square is a root 2, right? And the radius of the last circle or outer circle is a root 2. So we get the last region as this. Clearly the area of the first region, this we said this region as, and the area of the second region is more than the first region, and the area of the third region also more than the first and second region, okay. In area we can write R1 less equal to R less equal to R2, or we may write this R1 less than R less than R2 for these three regions. Now we consider a double integration as double integration e to the power minus x square into x to the power 2m minus 1 into e to the power minus y square into y to the power 2n minus 1 dx dy. Okay. Now we get the double integration over three regions, over R1, over R2 and over R3. And since R1 is the smallest and R2 is the largest and R is the middle of them, then we can write these three integration as double integration over R1. This is x to the power 2m minus 1 into y to the power 2n minus 1 into e to the power minus x square plus y square dx dy, less equal to double integration over R. This is x to the power 2m minus 1, y to the power 2n minus 1, e to the power minus x square plus y square dx dy, and less equal to double integration over R2. This is x to the power 2m minus 1, y to the power 2n minus 1, e to the power minus x square plus y square dx dy. Right? We write these three integration in this order because of this. Now we put in any one of the integration, either on the left or on the right. Because left integration, the region is a circle, and for the right integration, the region is also a circle. Okay, so we put for the left integration, and for the right integration we put x, this is equal to r cos theta, and y, this is equal to r sin theta. Clear? So we must get the range of theta. This is from 0 to pi by 2, and the range of r, this is from 0 to a for the region R1 because the radius is r, and r is 0 to a root 2 for R2 because here the radius is a root 2 for the outer circle. Okay, and theta, range of theta for both the circle is 0 to pi by 2 because for the first quadrant only. Okay, now we write any one of them because they are alike. This is theta equal to 0 to pi by 2, and this is r equal to 0 to a, and we know that for this transformation mod Jacobian, this is equal to r, and dx dy, this is equal to r dr d theta, right? And we put the value of x and the value of y, and we put here the value of x square plus y square. We get r cos theta whole to the power 2n minus 1 into r sin theta whole to the power 2n minus 1 into e to the power minus r square into r dr d theta, right? And this is given by integration theta, this is equal to 0 to pi by 2, and integration r, this is equal to 0 to a for r1 for the left integration, and this is r to the power 2m minus 1 plus 2n minus 1 and plus 1 because r is present here, and this is cos to the power 2m minus 1 theta into sin to the power 2n minus 1 theta into dr d theta. Okay, so this is integration 0 to pi by 2, and we write here cos to the power 2m minus 1 theta sin to the power 2n minus 1 theta d theta, and into r, this is equal to 0 to a r to the power, this is 2 into m plus n minus 1, 2 into m plus n minus 1 because 1 cancel out, into e to the power, sorry, there another term, this is e to the power minus r square dr d theta, e to the power minus r square dr. Okay, this integration is equal to the product of two integration. We clearly see that the first integration is this because this is 0 to pi by 2 and 0 to pi by 2 cos to the power 2m minus 1 theta sin to the power 2n minus 1 theta d theta. Okay, this is the same, and clearly this integration is here, the result is half into beta mn. So we put here half into beta mn. Clear? And this is equal to r equal to 0 to a r to the power 2 into m plus n minus 1 into e to the power minus r square dr. Okay, and similarly if we calculate the right side integration, then this is the same, and only change is r equal to 0 to not a, this is r equal to 0 to a root 2. Okay, and the middle integration is same like that, but the range of the integration is x equal to 0 to a and this is y equal to 0 to a, because this region is a square region and both the range are constant, x equal to 0 to a and y equal to 0 to a. Okay, so we write this term in the left side, this term remains same, and the term in the right side is similar as this except a root. Okay, we write here. Now by putting the value of left integration, right integration, we get the relation as this. Okay, the left side is half into beta mn integration 0 to a e to the power minus r square r to the power 2 into m plus n minus 1 dr, and the middle portion is same as the previous, and the last portion is half into beta mn integration 0 to a root 2 e to the power minus r square into r to the power 2 into m plus n minus 1 dr. Okay, now when we take a tends to infinity, clear? If a tends to infinity, then at first we get the radius of the first and the second circle as tending to infinity, clear? And so we get the limit of x is 0 to infinity and also y from 0 to infinity. That is the first quadrant or positive quadrant of xy plane. And we get also the range of square. Then the square becomes very large and occupy the whole first quadrant. So for the square, this range is 0 to infinity and 0 to infinity. So all the range are 0 to infinity for square, and the range of r for the circle, two circle, are 0 to infinity for both the circle, right? So this integration becomes by taking a tends to infinity. So we get taking a tends to infinity, we get, okay, half into beta mn, there is no change, and this integration becomes 0 to not a, then becomes 0 to infinity. And this integration is x equal to 0 to not a, this is infinity, also this is infinity. And the right side is also r, this is equal to 0 to not a root 2, this is infinity. And when we take this type of integration in left and this type of integration in right, these are the same integration, and this is the same as this integration. Already we done here integration 0 to infinity e to the power minus r square r to the power 2 into m plus n minus 1 dr. So we put the value of half gamma m plus n in right and in left. So we get half into half, that is 1 by 4 beta mn into gamma m plus n in the left, and the middle portion is integration x, this is equal to 0 to infinity, and we write here this is e to the power minus x square x to the power 2m minus 1 dx into integration y, this is equal to 0 to infinity, this is e to the power minus y square, and y to the power 2n minus 1, sorry, this is not m, this is n dy, and the right side is less equal to half into beta mn into gamma m plus n. Okay, and clearly this integration and this integration is like this integration. This is 0 to infinity e to the power minus r square r to the power 2m minus 1 dr, this is half into gamma m, and this integration is r to the power 2n minus 1, then this is half into gamma n. So we write the middle portion becomes, this is less equal to, this is less equal to half into gamma m into half into gamma n. So this is 1 by 4 into gamma m. And we see that the left side and right side are equal. Okay, and so we can write middle portion, this is equal to left side or equal to right side, because left and right are both same. So we get 1 by 4 into gamma n, this is equal to 1 by 4 beta mn into gamma n plus n. 1 by 4 cancel out and we get beta mn. This is equal to gamma n by gamma n plus n. Okay, and this is our proof. And we know that in this definition of gamma function, beta function, this is convergent only when n greater than 0. Also this is convergent m greater than 0 or n greater than 0. So obviously in all the cases m and n greater than 0. Okay, and this is very important relation between beta function and gamma function.